Hey, sorry guys, I started recording and then realized I forgot to hit record. So I'm starting over. So we're on notes 2, and this is polynomial zeros. So what I did here is I drew a little graph, and I said what we did the other day is we had this sketch, and we said that the zeros are where we cross the x-axis. So my zeros are where we cross the x-axis. Don't have to cross it, just have to hit it, right? And that these zeros are dependent on two things. It's dependent on the degree of the polynomial and the leading coefficient. All right, so if I had something like negative x to the 6th, I would say that this is even, because 6 is even, and this is negative. So the degree and the leading coefficient. All right, now, if I finish the sentence, it says the degree and the leading coefficient of the polynomial determine the end behavior. So what's happening out here at the ends? The factors of the polynomial determine the zeros. And this are the x-intercepts. Now we did this with quadratics. If you remember, one of the things that we did in quadratics is if we had something that said y equals, I don't know, x squared minus 2x minus 8, we would go in and we would factor this, and we would say x minus 4 and x plus 2, and then we would say these are the zeros. So being able to factor this, we would then go in and say, okay, we have a 0 at negative 2, and we have a 0 at positive 4. Okay, so we did this in Unit 6. All right, so go back and look at Unit 6 if you're confused. Now, if we see this already in factored form, then I can find my zeros. So remember, when I have this coefficient out here that has an x in it, then this means I have a 0 at this number. There's not anything there, but if I set it equal to 0, 2x equals 0, the only thing I can plug in for x to make it 0 is 0. So this 0 is 0. This one is x equals 3. Remember, it's opposite of what we think. We did this up here. And then my last one is x equals negative 5 over 2. So yeah, that's a fraction. It doesn't look good, but we know how to do that. Now, if we see this example, find the zeros of the polynomial, I can't do it in this form. So what I have to do is I have to factor this. Well, this is only 2 terms, right? So I can't use trial and error. So if I have 2 terms, I look at my greatest common factor, I pull out a 3x. What's left is x squared minus 4. Now I can check this, and I can say this is 3x cubed. 3x times 4 is negative 12x. Hopefully you see that we're not done. This is a difference of squares. So I'm going to keep going. 3x, x plus 2, x minus 2. All right? So again, I have 3 zeros. X equals 0, x equals negative 2, and x equals positive 2. Right? 3 zeros right here. Now, what we did our lesson yesterday in 8.1, we said that this tells us the maximum number of zeros we have. Well, this says we're going to have 3, and guess what? We had 3. Now, this doesn't tell us how many zeros we're going to have, but if I was to FOIL this all out, I would have a polynomial in this format. So, again, this is factored form, and this is standard form. So I have to move it from standard to factored form to find my zeros. Okay, so now we have this new concept of multiplicity. So if you think of multiplicity, hopefully what you see is multiply. And that's really what we're going to do. So what we're going to look at is when we have these in factored form, we're going to look at the number of times a linear factor occurs for a particular polynomial. And this is called the multiplicity. It's a fancy word, but it's going to be easy. You'll see what I mean. So, for example, I have this equation. So x plus 1 to the 5th, x minus 1. There are 2 linear factors. So a linear factor is going to be in the form of mx plus b. It's going to be a line. So here I have 1x plus 1. That's a linear factor. 1x minus 1, also a linear factor. So my two linear factors are going to be x plus 1 and x minus 1. We're not going to include the power. We don't include the degree. So I have x plus 1 and x minus 1. Those are my two linear factors, okay? But here's where this term of multiplicity comes in. How many times, so I'm going to ask this question, how many times is x plus 1 a factor? And the answer to that is 5. So the multiplicity for x plus 1, which is this one, how many times is it a factor? It's a factor 5 times. The multiplicity for x minus 1, well, I only see that one time. There's no exponent there, so this is going to be 1. Now, what this means is if I took this and expanded it out, which we will never, ever, ever do, it's saying this, x plus 1, 2, 3, 4, 5, x minus 1. That's what this is saying, okay? And like I said, we will never, ever, ever do this, but that's what it's saying. So what happens is, if we were to plug this all in and we got something that looked super funky like this, we would rewrite it here and we would just say that this value of -1 is a 0 5 times. Well, you can't graph that, so we just know that that point counts, okay? All right, so with this, let's go ahead and read this. It says, identify the zeros of each of the equations and label as x-intercepts, and then use the calculator to sketch each one of the graphs. So what we want to do is pay attention to the zeros. So here, this is in factored form, so this is going to be easy. So here I have a 0 at 0. It's not 0.5, it's at 0. I have a 0 at +2, and I have a 0 at -3. Okay? So when I plug this into my calculator, and y'all really plug this in so you get practice here. So x squared. Now I'm going to just start my parentheses, and I'm going to do x minus 2. And I'm going to start my parentheses, and I'm going to do x plus 3. So I'm going to type it in exactly like I see it. Sorry, there's a little bit of glare. Exactly like I see it on my form. And now I'm going to hit graph. Okay, so what I see is that I'm going to start up and go through this point, and then I'm going to hit this point here, and then I'm going to go through this point. Okay? This should have gone a little bit lower, but it's okay. That's not really what I'm worried about. Okay, so this says pay close attention to the x-intercepts of each graph. So what happened here is I crossed through this point. What happens here is I crossed through this point. What happened here is I did a U-turn. So I bumped the point and turned around. I did not cross. All right, we're going to come back to this. Let's do the next one. So I do not have a 0 here. This is no 0. Why? Because there's no x. If I go over here, I have x squared, so I have a 0. This is not a 0. So my zeros happen at -1 for this guy and +1 for this guy. All right, let's plug that in. -3, x plus 1, and now I'm going to square that. So here I hit the square button. And then I'm going to have x minus 1, and I'm going to hit the square button again. Okay, so this looks like this. Now I hit enter. All right, so here's what happens. So if I sketch this graph, I'm going to go up here and hit this, and then I'm going to come and turn around and hit this and come back down again. All right, so let's identify what happened. This was a bump. This was also a bump. I did not cross the axis. Here I crossed it, here I bumped it. All right, let's do the next one. I have a 0 here at -1, and I have a 0 at +1. Remember, these powers don't matter. I'm not doing anything with the powers right now. So let me go back in here. and I have x plus 1. This is going to be to the 5th power. And then I have x minus 1. All right, so if I graph that, ooh, this looks a little funky. So I'm going to come down here. I'm going to kind of even out so I don't cross right through. It looks like it just kind of goes flat for a minute. And then here, I'm going to cross through this. All right, so what happened? This one, I went right on through it. It just crossed right on through. But over here at -1, I did one of these things, right? So I'm going to call this a flat cross. Okay, now let's talk about this before we do the second section. So what I see here is I crossed and I crossed. All right, so that was this one. I crossed that one and I crossed this one. What you see is that the power on both of these is 1. All right, now what happened here at 0, this was my 0, at 0 is I bumped it. My power on that is 2. If I go over here, I bump the line and I bump the line. My powers are both 2. If I go to this guy, I crossed the line. My power is 1. And this one, I had this funky flat cross right here. My power is odd. Okay, so let's go down here and fill out this chart, and then we're going to go back and do these without the calculator. So basically, what this means is whenever I have an even multiplicity, so something squared, something to the 6th, something to the 4th, these are all even multiplicities, and these are my linear factors. So it doesn't matter if it's plus or minus, but these are going to be my linear factors. This means I'm going to bump the line. I am not going to cross. It bounces off the line and comes back down. So I call it a bump. Some people call it a bounce. But whatever is happening here, it's not crossing the line. That's the important part. So when it's even, what happens here is that we bump the line. Now, with odd, we're going to split this out into two things. If I have an odd, that's 1. Only 1. You're never going to see it written with a 1. It's just going to be listed one time. We are just going to cross on through that line. If I have any other odd, so x plus 1 cubed or x minus 1 to the 5th, any other odd power, we have our flat cross. We are going to cross. It's going to go through the line, but it's going to go through the line with this flat cross. All right, I know there's a lot happening here, so be patient. We're going to do this one without the calculator. So I have a 0 at 0. I have a 0 at 2. And I have a 0 at -1. Okay, so I have to think about what my end behavior looks like. So what I'm going to do is I'm going to add up all my zeros. So I have 3 zeros here, and I know that because of this. I have 1 0 here, and I have 1 0 here. So I have 1 plus 3 plus 1, so that is going to be 5. So what I have here is an odd positive function. This is odd positive, and I know it's positive because this x is positive, and this x is positive, and this x is positive. So I'm going to have a down up. So I'm going to start here. I'm going to end here. So at -2, this is odd. If we go back out down here, if I have an odd, I do a flat cross. So when I get to -2, I'm going to go here and I'm going to do this kind of flat cross thing. Okay? Now, my other ones, this is a multiplicity of 1, and this is a multiplicity of 1. So if I look at this, when it's a multiplicity of 1, I'm just going to cross right through. So what happens is I cross through this point, and I cross through this point. All right, let's look at this one. First of all, these are all multiplicity of 1. So if they're all multiplicity of 1, I'm just going to cross right on through those points. So let me put them on here. So my zeros happen at -3, -1, and +2. All right, so I have 1, 2, 3 x's, but I have this negative here. So this is going to be odd. So 1, 2, 3, negative. And odd negative is going to be up, down. Because these are all multiplicity of 1, I'm going to go up, down, and I'm just going to cross, cross, cross. All right, let's do one more. So I have 1, 2, 3 zeros. 1, 2, 3. So I have 3 zeros. So this is going to be odd. This is positive, and this is positive. So odd, positive is going to be down, up. My zeros happen at 0. That's this one. And +3. So down, up, that's where I'm going to end. Now, this is a multiplicity of 2. And we said when it's a multiplicity that's even, we're going to bump the line. All right, so I'm going to go through this one first. I go through 0, I just cross right on through. But with this one, because it's 2, I have to bump the line. So I'm going to hit it, bounce off of it, and come back up. So whether you say bump, bounce, whatever works in your vocabulary, whatever you think about, I didn't cross. Everything else we crossed. We had a funky cross, we have regular crosses, and then we have a bump. Okay, so let's practice this. So, how many zeros do I have? So I have a 0 at x equals -2, and I have 1 at x equals 1. -2 and 1. So I'm going to go right over here. I have -2 and 1. And it's great when it's already in factored form like this. So the degree of the polynomial, I have 1, 2, 3. So this is a third degree polynomial, which is odd. My leading coefficient, this is positive, so it's going to be positive. So odd positive is down, up. Oh, that's here. Down, up. That's my end behavior. So I know I'm going to start here, and I'm going to end over here. Now I'm going to ask myself what's going to happen. Well, this is 2, so it's even, so this is going to be a bump. This is 1, there's no exponent, so this is just going to be a cross. So at -2, I'm going to bump the line, and at 1, I'm going to cross the line. And if you've got your end behavior arrows, you're just going to meet up with your end behavior arrows. That's all that's going to happen. All right, let's do this one. My zeros happen. There's no x here, so this is not a 0. There's no x. So my zeros happen at -2, +1, and -3. So now we look at the degree of the polynomial. I have 2, 3, 4. Nothing here. There's no x. 2, 3, 4. So it's a fourth degree polynomial, which is even. My leading coefficient, so positive, 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 makes it negative. So even negative is going to be down, down. So if I put my zeros on the graph, I have 1 at -3. I have, this should have been -2 up here. -3, -2, and +1, and my end behavior is down, down. All right, so what do I know? At -2, I'm going to cross. At -3, I'm going to bump. And at +1, I'm also going to cross. All I'm doing is looking at the exponents again. So what comes first is -3. So -3 has to be a bump. So I'm going to bump and then cross and then cross. Now, if I was to graph this in my calculator, you're going to see that this might go lower, it might be higher. We don't know. We don't care so much about what's happening on this part yet, right? We just care about what happens at the 0. Am I bumping it? Am I crossing it? And what is my end behavior? What's happening to my arrows at the end? All right, next one. So, excuse me, my zeros happen at x equals 2, x equals 1, x equals -3. So the degree of this polynomial, 3 plus 4 is 7, plus 1 is 8. So this is an 8th degree polynomial, which is even. My leading coefficient, positive, positive, positive. So even, positive, is up, up. Oh, I don't know why I keep doing that. Up, up. So my end behavior is there. So I know I'm going to end here. I'm going to end here. I can put my zeros. So negative 3, positive 1, positive 2. And let's look at this. So this one's going to be a cross. This one, even though it's a 4, it's even. So remember, all evens are bumps. And this is odd, but it's not 1. So this is going to be a flat cross. All right, so that one's first. So I'm going to come down here and I'm going to try to flat cross through this. So do you see a difference between this one that goes straight through and this one, which is kind of flat crosses? So I have a flat cross, and then at 1, I'm going to bump, and at 2, I'm going to cross. All right. What I'm going to do is I'm going to go ahead and pause the video, and I want you to practice these, and then after you do each one, I want you to unpause the video and check and see what you did before you do the next one. Okay? So pause the video right now and try letter A, and then come back and check it. All right, here's the first one. So I have 3 zeros. This first one is a flat cross, so this needs to look like a flat cross, and then a regular cross and a regular cross. Okay, so with my degree polynomial, it's 3, 4, 5. All right, pause it and do B. All right, here's B. So no x on this first term, so that's not a 0. You only have 2 zeros, negative 1 and 1. My degree of my polynomial is 2, 4. Because this is negative, my leading coefficient's negative, so negative even is down, down. And what I see is both of these are bumps. So with this graph, I'm going to go bump the line, and I come back down. Okay, and again, maybe you drew your graph and you went clear down here, and then you went this way. That's okay. I don't care about what's happening here. All we care about what's happening is end behavior and zeros. That's all we care about. Okay, go ahead and, oops, this should be C. Go ahead and do C, pause the video, and then come back. Okay, so hopefully you saw that you couldn't do it this way. You had to factor this. So this is not factored. So I gave you factored form up here. This one's not, so you have to factor it. So first thing I did is I pulled out an X, and then I did trial and error, and this is what I got. And because these two terms, x minus 3 and x minus 3 are the same, I rewrote it showing the multiplicity. So I rewrote it like this. So I only have 2 zeros, 0 and 3, right? I can go back to my initial problem and see that my degree is 3 and my coefficient is positive. So this is the easiest way to find what your end behavior looks like when it's in standard form. So my zeros are at 0 and 3. Because this is a multiplicity of 2, I bump the line. All right, one more that I want you to try. I want you to go ahead and try D, and obviously on D, you're going to have to factor again. All right, so here's what we end up with. Now, this is still a linear factor, even though that looks funky. So what do we have here? If you need to do this, we would say 2x plus 1 equals 0. So move the 1 over. So x equals negative 1/2. So I have a 0 at negative 1/2. So it's in between 0 and negative 1, right? And what I have here is that this is a 0. The 0 happens at 0. This is a bump. So I go through at negative 1/2, I bump at 0, and then I come back up here at x equals 3. Okay, I think on your homework you're doing a little bit of everything. You're writing the equations based on the zeros, and then you're doing some graphing.